Good day. Today we are starting the very first lesson in Unit 2. Unit 2 is all about functions. This particular lesson is 2.1 and it covers domain, range, and functions generally. What you're going to be able to do is you're going to identify the domain and range and whether a relation is a function. And this video supports the Algebra 2 lessons, Excel lessons, that is, D1 and D2. And again, you're going to be able to take notes on these. In fact, that is the requirement in your math notebook. You will also explain how you could use what you learned to solve a problem that you think is similar. And you will also upload today's notes to me via the Student View Dropbox by 11:59 p.m. Wednesday of next week. Now, I have that Dropbox open at this time. If it does not work for whatever reason, then send it to me by email. Okay. So, in this first example, we're going to identify domain and range. And we're going to determine whether the relation shown is a function. So what is a relation? That's really the kind of gatekeeping issue. So whenever we graph points on an XY coordinate chart, the first coordinate is considered the X coordinate, and the second coordinate is considered the Y coordinate. So, for instance, -3, 6 could be two coordinates, and these two have a relationship with one another. So we call this a relation. This is just, generally speaking, a relation. Now, when you have a number of relations graphed such that you have one output for each input, then you can also state that you have a function. So if you look at the first example here, each input must have just one output. So here -3 is an input. It would be your X value. In fact, that would be what the first one would be here, although the output is different. -3's output and only output is 4, so that passes the test of a function, excepting when you get to -1. -1 has two outputs. One is 0 and one is -2. So because of this, this is not a function. It's a relation, because any sets of pairs is a relation. So relation, but not a function. All right? Okay, and so how would you show these inputs and outputs? You would show them as ordered pairs. So the first one would be -3, 4. The second one would be -1, 0. The next one would be -1 and -2, and the last one would be 2 and 1. So again, because of this issue of -1 having two outputs, it wouldn't be a function. So there's more than one way that we can show a function. One is as a group of inputs and outputs. This is another way we sometimes see inputs and outputs. Sometimes it's vertical in vertical columns, and we have these arrows to show whether or not you've got more than one output for any given input. In this one, it's another what we call T-chart. This is a T-chart, and so in this case, -1 has only one output. 0 has only one output. 1 has only one output. 2 has only one output. 3 has only one output. Now, it is true that that the outputs are all, they relate back to the inputs such that each of these would still be a function. And the reason is because you still have for each input only one output. -1 only has 5 as its output. 0 only has 5 as its output. 1 only has 5 as its output. 2 only has 5 as its output, and 3 only has 5 as its output. Over here on the left, -3 only has 4 as its output, but -1 has both 0 and -2 as its output. So again, fails the test of a function. So for a function to be a function, each input can have only one output. Okay? And usually we see them showing as x and y, x being an input, so this is normally the input, and y is normally the output. We could use other letters, and in some cases later on down the line, you can see where we will reverse the x and the y, so the columns will get reversed, so that can cause some changes. The other thing to note is that when you graph a function, that function must pass something called the vertical line test. So to determine if a relation shown in a graph is a function, it must pass the vertical line test. Now, I'll show you what that is in a moment. So, you should understand that these are two tests to determine whether a relation is a function. Okay? This one is a relation all by itself because there are no other coordinates. This one is a relation because, again, it doesn't pass, it has more than one output for each input. This one here is a function. So this relation is a function. Because, and then it's this rationale that you see down here, to be a function each, to be a function, each input can have only one output. Okay. All right, so I need to bring this up here so you can see this a little better. And what I'm going to ask you to do now is to take a picture of this so that you can make notes. But remember too, this is a video, so you can easily, stop this if you want and take a picture, or not. But you can, write your notes. You've got all kinds of options when you have a video. Start it, stop it, rewind it, that kind of thing. All right. So now what I want to do is just show you some examples of other ways that you could see a function and how you would set up the set for it. So I want to I've got right here some ordered pairs. So this is an example of a function because there's more than one ordered pair. So this is, well, maybe it's a function, it's a relation. So this is a relation. Can it also be a function? That's the question. And so we've got -2, -3, 1, -1, 0, 0, -1, and 3, -1. So let's look at whether or not we got more than one output for each input. So -2 has an output of -3, but it has no other outputs. -1 has an output of 0, but it has no other outputs. 0 here as an input has -1 for an output. It has no other outputs. And -3 as an input has -1 as an output. And it's true that both 0 and -3 have the same output, but those are different inputs. So each of those inputs has only the one output. So this is a function. This is also a function because, again, there is only one output for each input. Now we also want to know what the domain and range is. So D means domain. And I can never remember how to spell domain, M-A-I-N. So the domain, or D, is going to be all the X values in the set. So all the X values in the above set. So this is X, this is X, this is X, this is X. So that would be, and so if you want to set up a set, you always do a curly Q parentheses, and you fill this in with -2. That's the first X. The second X is -1. So comma -1. The third one is 0. The fourth one is -3. And you close the curly Q. Now R is range. This is called the X values. Okay, range, or it's all the X values rather. Let me change that. So all the X values. Let me rewrite it. So the domain is all the X values shown. We'll just say all the X values. Now the range is all the Y values. So those would be -3. So this is your Y, this is your Y, this is your Y, this is your Y. So -3 is the first one, curly Q, parentheses, so -3, comma, then I have 0, comma, then I have -1, comma, and then I have, oh, I've got -1 again. So now whenever you get two domain values or two Y values that are the same, like here and here, these are two Y values that are the same, so it's two range values, you only show it once. So you close your parentheses like this. Domain and range is meant to only show the actual values in the set. So whenever you're talking about the set of values for a particular function and you're putting it in set notation, which has these curly Q parentheses, you only show each number in the domain and each number in the range once. All right, so the question, is it a function? We said yes, because there is only one output for each input. All right. So this is a separate problem here. So this is a table of values. So the question is, do we have one output for each input? Well, okay, this input, -2, has 1. But all of these are -2. So that means we could just go like this. -2 goes to 2, -2 goes to 5, and -2 goes to 7, because these are all the same. And since they're all the same, that means that this input has 1, 2, 3, 4. So this relation is not a function, because the input, and in this case -2, has 4 outputs. Okay? Only 4, or it has a 4, and you can only have one output. So a function, again, has only one output for each input. Okay? All right. So if I were to graph this, it would look like this. Here's my XY graph. And so I've got, let's say this is -2, and then I've got 1, 2, I'm going to run out of space here, so let's redo this. Do it down here. Okay, so here's -2, x is -2, and this is y, and then I've got, I go up to 7. So 1, 2, 3, 4, 5, 6, 7. 7, 6, 5, 4, 3, 2, 1, and this is 0. All right, so if I were to graph this set of points, I'd have -2, 1, x is -2, y is 1. Then I would have x is -2, y is 2. Then I would have x is -2, y is 3. Oh, 5, I'm sorry. -2, y is 5. X is -2, y is 7. So up here. So if you look at these, what you end up is you can draw a vertical line through these and you hit the same point 4 times. Remember, this one here is not a point. So again, fails the vertical line test. Right? Okay. So now what we're going to do is we're going to just quickly look at some graphs. So when do you use only one output for each input? Usually you use that when you're dealing with ordered pairs or a table of values, right? Something of that nature where you're just looking at x and y coordinates and you don't have it graphed. But the other way to look at the same thing is the vertical line test. So I took this ordered pair here, this table of values, x and y, or it's sometimes called a t-chart, and I graphed it for you, and I showed you that the vertical line test applies to the graph of this. But here we said, well, it's not a function because the input has 4 outputs. this is the same thing, but here we see the same relation fails the vertical line test. So all you need to do is show one or the other of these failures. There are really two alternative tests to prove whether or not you've got a function. Okay? Okay, so going back to this, these are all graphs. And they're graphs of different functions. And so these are kind of weird looking graphs. They aren't linear functions, obviously. You may know from your past experience that this is an absolute value function. You may not know what the heck this is, but this is actually the inverse of this absolute value function. So you'll notice in this absolute value equation, the x and y get switched over here. So in the case of this absolute value function, wherever I were to put a vertical line, and I'm just going to arbitrarily put one there, it only passes through this absolute value function once. So this is a function because the vertical line passes through the function once. Oops. Function just once. So when it passes through it just at once, then there's only one output for each of these inputs, because the outputs are all the y values. So, for each x value, as we creep along here, these are all x values coming along here the x way. So from here to here and extending off into the distance, they're x values, and then the y values are what you see that are going the up part. And there's only one output for each of those inputs. But on this one, this is the inverse of the absolute value function. You'll notice that this is not a function. So this is not a function. Because you have two outputs for each input. One here and one here. And wherever you do the line, you're going to get two. So because you have two outputs for each input, so the vertical line test fails. Well, the test itself doesn't fail, but so the vertical line test indicates this is not a function. So what is it? It is a relation again. This is a relation, but not a function. Okay. All right, well, let's look at this first one here. Well, I could put a line through here. I could put a line through here. I could put a line anywhere along here. And you'll notice in each case, this passes the vertical line test. So passes the vertical line test. There is only one output for each input. So the conclusion is, so this relation is a function. What about this one? Now this is an oval, and yes, you can come up with an equation for this. You can come up with an equation for this. I don't happen to have it up here. It's a more complicated equation than you're accustomed to seeing, whereas you're always familiar with at least an absolute value equation. This one looks a little funky because, as I said, we reverse the x and the y, but that's again going to be the converse of this. Okay. So here I got a vertical line that's going through this oval, and I could have it going through any place. And so, you know, you can test this, and you can say, oh wait, there's two outputs for the input, which is in this case happens to be the y-axis. So the y-axis is where x is 0. So where x is 0, there are two outputs, and anywhere along here, in fact, you can. So here's where x is 5. You still have again two outputs. This is approximately, I'm not sure what it is. It looks like these are units of 1, so maybe it's x is 5, y is 1, x is 5, y is negative 1, 2, 3, negative 3. So 5, 1, 5, negative 3. This is 0, 1. Well, it's a little bit different. It's a little higher. So I'm not sure what it is. I'm not going to go into it just by guessing. But the idea is you got two. You're showing these two inputs. That really means that the input 5 has these two outputs. Okay? So this relation is not a function. It does not pass the vertical line test, which is again only one output for each input. And I'm not going to repeat the rule over and over again about the vertical line test, because I've said it multiple times here and I've written it in multiple places. Okay? All right, so that's basically it. That tells you a bit about how functions behave. Functions, again, have only one output for each input. When graphed, you can see visually that if you have more than one output for each input, then a vertical line will pass through the function or the relation more than once. And that means it's just a relation, not a function. Also tells you that this information has told you that all of these functions are also relations. So a function is a subset of relations. Okay? All right. So we're going to be applying this as we go to all kinds of other equations. So quadratic equation, absolute value equations, piecewise equations, equations for circles and ovals and other conic types, well, not conic, but other circular type functions, exponential functions, radical functions. We can go on and on. There's a whole bunch of them. All right, so we're done with this one, and this was a little long, but I wanted to make sure we got everything that we needed to. So you're done for this particular episode, and we'll talk to you soon.